You're welcome back to a session with your friend Edu Ada. You're welcome back to my channel, Mathematics with Edu Ada. Like I've always said, please don't forget to like my videos. Don't forget to subscribe. Hit the subscription button. There's a subscribe button there. Hit it. Just mark this one like, subscribe, and make your comments. Make your comments also. I would appreciate that. Quickly today, we continue with the series we started under application of differentiation. And under this, we'll be treating rate of change. We have treated gradients, slope, and we treated the concept of minimum, maximum, critical points, turning point. What happens at those points? I've treated that in the previous videos. So now we'll be going to rates of change. I have these two examples to buttress this concept. What is rate of change? Rate of change basically means the change in y or change in quantity 1. So is it rate of change means the ratio of the change in quantity 1 to a change in quantity 2. Yeah, that's what rate of change is. And this is we're applying what? Chain rule in this place. Chain rule, yeah. So if you're applying chain rule here, like we know, our dy, if you're applying chain rule, the y dx is always equals to what? Depending on what other parameter or quantity you have brought out of a function or function. So if you can have probably represented a function with something like you can say you have the u, the x. Look at it. You have the y, the x. So you can say you have the u, the x times, then you have the x. Okay, since y will be equal to something in terms of u, so you can say the u dx times the y. So you can let me use the y dx because there's something I will use this same concept to explain something to you here. So we have the y, the u. It's, look at what I'm doing here. The y, the x, I'm writing out the y first with respect to another quantity, then this other quantity, which is the u, times, you represent solving this with respect, differentiating this with respect to x. So the u, the x. Are you getting that? So here, which means if you cancel out this, you are still having this, the y, the x, to be equal to the y, the x. It's just manipulation. We are arriving at the same point. But observe what I did here. The y, the x equal to the y, the u. I'm starting with this concept. I'm differentiating a new function, which is u. I'm taking it like if I have something like this. 3x plus 2 all raised to the power 5. So if y is equal to this, so this, I'm looking for this, the y, the x, I'm differentiating this function with y with this function with respect to this dependent variable, right? So I mean independent variable, this is dependent variable. Good. So here I can say u to be equal to 3x plus 2. You get that? So this is where I'm bringing out this u. So if u is equal to this, then my y will no longer be this, now be u raised to the power 5. So that's where this one came from. So the y, the u differentiates a new function out of this major core function, the y, the u, then that will give us what? 5u raised to the power 4. Then since y is now equal to this, you can differentiate u itself. Yeah. You can differentiate u itself. So you can say, since you have y to be equals to this, and u is in terms of whatever you call it. So you can call now du dx, this itself. So dy du times du dx, then you bring that in, then you solve this out, you're done. Do you get? So that is the main concept that I'm explaining in this place. Now we'll move on. I don't want to waste much time on that. So it's a function of function. I will treat that in my next video. So let's solve a question here. A circle with radius 5 centimeters at its radius increasing at the rate of this 0.5 centimeters per second. This is the rate, this is the rate of the change per time. So what will be the corresponding increase in the area? First, what will be the corresponding increase in area? And I'm looking for that. So now you have been told increase in area, that will be dA. Increase in area, dA dt. We don't have it. Increase in area. And increase in area, dA dt, using chain ruler. Follow what I did the other time. So this one will be dA d something. dA d what? What other parameters do we have here? We have radius. We have the rate at which the radius increased. So we're supposed to have dA dr times now the rate at which the radius increased. That will be dr dt. So that's the rate at which the radius increased. Now, how do we get this out? We don't have the ADR. We have the RDT, which is this. We don't have the ADT. But we can get the ADR because the ADR means differentiation of what the area of this circle with respect to the radius. Do you get? So since we know A to be the area of a circle is pi r squared. Are you following? So if the area of a circle is pi r squared, automatically the A differentiating this is a function with respect to this r, the ADR will be equals to 2 comes down, that will be 2 pi r. But when we've been told when that's the radius of 5 centimeters, so the A, the R can be equals to what? 2 times this. Okay, 5 centimeters, right? So that will be 10 pi. Can we get that out? So good. So the ADR is now 10 pi, right? So the ADT can now be equal to the ADR, which is 10 pi, times the RDT, the rate of change, and rate of change itself is 0.5. So that will be 5, let me use 5 over 10. So what do we have? This can cancel out this. So 5 pi. Automatically, the rate of change of the area is 5 pi. Question 1. Let's solve question 2. Now let's write this question. The question says, let's pick another concept entirely. The volume is increasing at a steady rate of 18 pi meter cube per second at what rate is its radius changing when it is 6 meters. Now we solve this solution. Let's go on to the question again. It says the volume of the hemisphere is increasing at a steady rate of 18 pi meter cube per second. This is what? Meter cube, this volume, right? So it means we have the V, the T. Volume respect, in terms of rate, so that's the V dt. The ratio of the increase in volume and the ratio per time. So we have the V dt to be equals to 18 pi meter cube per second. Then, at what rate is this radius changing when it is this? So that is at what rate is the radius changing? The R dt. I don't know what I will write next. How do you get that? Come to this place. So the V dt should be dV. The what? The V dr. Since radius is involved, times then the R dt. Don't forget this is times. By dot multiplication. So here we are guessing this. Now we have the V dt, which is this. We don't have the V dr. And we don't have the R dt. So but we can get this. We can get this from the formula of volume of a hemisphere. Don't forget, volume of a hemisphere should be from volume of a sphere. Volume of a sphere is 2 pi r squared. Okay. So that when you differentiate, so that will be 2 over 3 by r that will be 2 pi r squared. Yes, 2 pi r squared. So if you differentiate this normally should be, so this is volume, of hemisphere. So if you differentiate this, you have the V, the R, the V, the R. What happens? You are not to just differentiate anyhow. You get? So if you have this to be what? Value do we have it to be? So you have the volume to be that 2 over 3 pi r raised to power 3. Okay. I've actually changed it back to the area. So this is what the volume is supposed to be. To be 2 over 3 pi r raised to power 3. So if you are making it 2 over 3 pi r raised to power 3, and you are now differentiating. So what do you have? This multiplies this. That will give you 3 times 2 upon 3 times pi r reduced by 1. So this cancel out this. That becomes 2 pi r raised to power 2. But when the radius is 6 meters, it will be r times r 36 times this. This will be 72 pi. It's 72 pi, right? Now, when we have gotten our dVdr to be 72 pi, and we are looking for the r dt. The v dt is 18, right? So that will be 18 can be equal to 72 pi times the r dt. So the r dt, of course, by the time you divide both sides, you have 18 upon 72, you have pi. You get? So what do you have? That becomes what? 9 here 2, 9 here 8, 2 here 1, 2 here 4. So that becomes 1 over 4 pi, and that is like 0.25 pi. That's if it's in decimal, you get the answer, and you are done. Thank you for joining me. Please, kindly subscribe. If you have any comment and you want to reach me, of course, you can reach me on 234-8164-86-9470. Via WhatsApp, via Telegram, via call. I'm good to go. Thank you very much, and see you again.